Hello everyone, hope you are all doing well. This is Vidyashree. In this video, I will be telling you a memory tip using which you can remember the reactivity series of metals very easily so that you can use it whenever it is needed. So before moving into the trick, you need to know what is reactivity series of metals, right? So what is reactivity series of metals? It is a list of metals that are arranged in the decreasing order of their reactivity. So let me write reactivity series. So as I told, reactivity series is list of metals arranged in the decreasing order of their reactivity. So means that we are going to arrange metals in a list such that it is in the decreasing order of the reactivity. So when I tell it is in the decreasing order, it means that on the top of the list we have highly reactive metals. So you can write highly reactive metals present at the top of the series. So meanwhile, it means that the metals which are present at the bottom of the series are less reactive. So least reactive metals present at the bottom of the series. Now you might have a question that why do we need to have a reactivity series of metals? So our question is why reactivity series? What does it do? If I answer this question, so using this reactivity series, we can tell whether a metal can displace another metal from its solution in a single displacement reaction. So it means that whenever a displacement reaction is taking place, means whether a displacement reaction is possible or not, that is told by the help of reactivity series. As I told, a metal which is present at the top of the series is highly reactive. So this highly reactive metal can displace a metal which is present at the bottom of the series from its solution. So why do we need to have reactivity series? It is that it can tell, so we can know, means to know whether a metal can displace another metal in a single displacement reaction. We have a lot of metals that are present in the periodic table like sodium, potassium, magnesium, calcium, gold, silver, copper, zinc, nickel, iron. Okay, all these metals. So how they are arranged, right? There is a particular order in which these metals has been arranged according to their reactivity. So that is what is called as reactivity series. So as I told you in the beginning of this video, now this is the time for us to know what is that trick to memorize this reactivity series for metals. So let me write that particular trick and I'll tell you how you can remember the elements or the metals of reactivity series using that particular memory tip. Here we go. The memory tip is, please stop calling me a careless zebra. Instead, try learning how copper saves gold. So I'll write that. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. Though there are a lot of elements that is present in the periodic table, so this memory tip will help you to remember those metals which are listed in your 10th standard NCERT textbook. So here, please, you can remember about potassium. So that is the first metal in the reactivity series, which is represented by K. Stop is used to remember sodium, which is represented by Na. It is the symbol. Calling stands for calcium. It is represented by the symbol Ca. Me is used to remember magnesium. Symbol is Mg. A is for aluminium. Symbol is Al. Careless represents carbon. Symbol is C. Zebra represents zinc. It is Zn. Zinc symbol is Zn. Instead represents iron. Symbol is Fe. Then we have Tri, which represents the metal tin, represented by the symbol Sn. Then we have learning, which represents lead. Its symbol is Pb. How represents hydrogen. Symbol is H. Then we have copper. So it represents copper only. So it is copper. Symbol is Cu. Then saves tells about silver. Symbol is Ag. Gold is gold. Symbol is Au. So using this memory tip, you can easily remember this reactivity series for metals. Again, I'll tell this memory tip. It is, please stop calling me a careless zebra. Instead, try learning how copper saves gold. So please stands for potassium. Stop is for sodium. Calling is used to recall calcium. Me for magnesium. A for aluminium. Careless for carbon. Zebra for zinc. Instead for iron. Try for tin. Learning for lead. How is for hydrogen. Copper is copper. Saves for silver and gold. So as I told earlier, the metals which are present in the top of the series are highly reactive. So here, these metals which are present on the top of the series are highly reactive. I have written in short HR, which means highly reactive. Potassium, sodium, calcium, magnesium are highly reactive, and those which are present in the bottom of the series, copper, silver, gold, are least reactive. And those metals which are present on the top of the reactivity series can displace the metals which are present at the bottom of the reactivity series. We have learned a memory tip to memorize reactivity series of metals. Now proceeding further, let us see whether we can predict whether we can find a metal can displace another metal with the help of this reactivity series. So as you can see on the screen, I have written the reactivity series along with the trick on one side of the screen. Now I am considering the example. So here, if I consider the reaction between iron and copper sulfate solution, whether iron can displace copper from copper sulfate. So this is an example for displacement reaction, right? So iron, can it displace copper from copper sulfate solution is the question. So what we have to do is whether this reaction is possible or it is not possible. We have to check it with the help of reactivity series. If iron is present above copper in the reactivity series, then iron can displace copper. Let us check with the reactivity series. So in the reactivity series, we have iron here in the middle of the series and copper at the bottom of the series. A metal which is present in the top is highly reactive and a metal which is present in the bottom is least reactive. So iron is more reactive than copper. So iron can displace copper from copper sulfate solution. And we get iron sulfate and copper. So this results you can observe here on the screen. Iron nail, if it is dipped in copper solution inside a test tube, the test tube has to be sealed. So you can see here in the first test tube, we have a new iron nail that is dipped in the copper sulfate solution. So this copper sulfate solution is blue in color. After a few days, if you observe, you see that the iron nail is coated with a brown layer. Okay, that is copper that is displaced from the copper sulfate solution and it is deposited in the iron nail that you can see here. The iron nail which we had placed is coated with a brown layer now, that is of copper, and the color of copper sulfate solution which initially was there, that it turns into light green or it nearly becomes colorless. So blue color of the solution has been changed into light green or it has become colorless, and the iron nail which was clear before has a brown color coating now. So this iron is capable of displacing copper from copper sulfate solution. So the copper that is displaced from the solution is coated over the iron nail. So this is how, using reactivity series, we can predict whether a displacement reaction is possible or not. Now let me consider one more example and let us try to predict whether that particular metal can displace another metal from the metal solution. Let me consider a similar example. Now instead of iron, if I consider zinc. So zinc plus copper sulfate, whether this reaction is possible or not. Let us check it out from the reactivity series. So in this reactivity series, zinc is present almost at the center and we have copper at the bottom. So when you compare the position of zinc and copper in the reactivity series, clearly we note that zinc is present at the top and copper is present in the bottom. So zinc is more reactive than copper and zinc can displace copper. So this reaction is possible. So this zinc can displace copper and we get zinc sulfate and copper which is displaced from the copper sulfate solution. So similarly, if I consider another example and if I tell silver, can silver displace copper from copper sulfate solution? Let us check with the reactivity series. We see that copper and silver both are present in the bottom of the series, but you see silver is present below copper in the reactivity series. Means among copper and silver, copper is more reactive. Silver is less reactive than copper. So can silver displace copper? No, right? Because the metals which are present on the top of the reactivity series can displace the metal on the bottom. So among copper and silver, copper is highly reactive. So silver cannot displace copper from copper sulfate solution, and this reaction is not possible. So here I can write no reaction. I hope this is clear. So the trick to memorize reactivity series is, please stop calling me a careless zebra. Instead, try learning how copper saves gold. So this is the tip using which you can remember the reactivity series. And to predict whether a displacement reaction is possible, you should check whether the metal is highly reactive or less reactive. And you should remember that highly reactive metal can displace less reactive metal in a single displacement reaction. I hope you have understood the concepts that is taught in this particular video. I'll meet you in my next video with a new trick. Thank you for watching. Stay connected, keep learning, take care, bye-bye.